Example 20, we want to verify this identity. And once again, the left side, it's just coincidental that the left side, sometimes you want to start with the right side, but on this one, the left side's definitely the more complex side. So I'm going to start with that. So I'm just going to write that down. So we have sine of x plus pi over 4, pi over 4, plus sine of x minus pi over 4. And I want to turn all of that into that. So the x is trapped inside these sine functions, but I have a way to separate things, and this is where my sum difference formula comes in. So the first is sine of x plus pi over 4, so I'm going to use this identity to expand it out. So it's sine, and I'm going to do this in colors so you can see the difference because we're going to use two different identities. So I'm expanding this first, and I'll do that in red. So it's sine of the first thing times cosine of the second plus sine of the second thing times cosine of the first. Then I need to do the same thing with this guy, except now I'm subtracting inside. So the plus sign I'm writing comes from here. So it's sine of the first thing, cosine of the second, minus sine of the first, cosine of the second. So now let's see if there's anything we can clean up here. So I see that I have a sine pi over 4 times cosine x and a negative sine pi over 4 times cosine x. So these two add up to 0. This is a sine x times cosine pi over 4, so there are two of them. So now I can say I have 2 times sine x cosine pi over 4. However, pi over 4 is a special angle. We actually know what cosine of pi over 4 is. So this is 2 times the sine of x times the square root of 2 over 2. This 2 cancels this 2. I'm going to pull the square root of 2 out front, and we found the right-hand side. So we proved the left equals the right.